All right, guys, let's talk about 9.5. 9.5, the title is called the dot product, okay? So the dot product of two vectors, vocab, here we go. If vector v is some given a subscript 1 in the I direction plus b subscript 1 in the j direction, and a given vector w is a subscript 2 in the I direction and b subscript 2 in the j direction, v vector dot, okay, w vector is equals to components a1 times component a2 plus component b1 times component b2, okay? And I want you to be very careful that the answer is not a vector, okay? So if we're doing the dot product of two vectors, the answer is not a vector. Keep that in mind. What are some properties of the dot products? It is definitely commutative, okay? So what you have is the dot product of v dot w is the same thing as w dot v. Okay? It is distributive. So if you have vector u, not a unit vector, just so you have an understanding, dot the sum of vector v and w, it is now vector u dot vector v plus vector u dot vector w. It also has a zero product property. So if I take zero vector and I dot v vector, and there goes that block box, right? It equals to zero vector. Okay. And one thing I want to add on is if I were to do vector v dot vector v or itself, okay, and it's the same thing as if I were to take the magnitude of v and then square it. Okay, angle between the vectors. So if, there goes the magic box, if vector v and vector w are non-zero vectors, and okay, if vector v and vector w are non-zero vectors, let's do a comma, how about that, and not the word and, comma, the angle, let's call it theta, and restriction for theta again is between 0 degrees and 360 degrees, or if we are talking about in radians, we can also do between 0 and 2 pi, okay? So theta is restricted with one positive revolution, and if theta is between, so the angle theta is restriction, one positive revolution, and is between vector v and vector w. Theta is determined by cosine of theta equals the dot product of v and w, all over the magnitude of vector v times the magnitude of vector w. Okay, the reason I can say times on the denominator is because on the denominator, when I find the magnitude, those are constant numbers. And with constant, I can say multiplication. With vector, I have to use the terminology dot product. Next, parallel and orthogonal. Orthogonal is really a fancy word, guys, for perpendicular. Okay, here we go. Parallel. If vector v, okay, and vector w are, this symbol means parallel, okay? They are parallel if there is a non-zero scalar, let's call it alpha, so that vector v is exactly the same as the scalar times vector w. In this case, the angle, let's use theta, between vector v and vector w is either 0 or pi, okay? Or you can say 0, 180 degrees, okay? Next, if the angle theta between two non-zero vectors, let's call it vector v and w again, okay, is pi over 2 or 90 degrees, okay, then vector v and vector w are orthogonal. That means those two are now perpendicular. Well, piggyback on that, okay, kind of subscript here, if the dot product of v and w, it equals to 0. Well, the zero product would say then either v has to be 0 or w has to be 0, right? That's the only way that when you multiply two numbers equals 0, one of it has to be 0. Then, if that's the case, cosine of some angle between these two has to be 0. So cosine is 0 has to be at pi over 2, right? Or 3 pi over 2. So if it's at pi over 2, then we can say that, okay, then we can say that these two are perpendicular or orthogonal, okay? Next subscript of that is 0 vector is orthogonal to every vector. Okay. So just to recap really quickly is that two vectors are parallel if the angle between them is 0 or pi. Two vectors are perpendicular or orthogonal if the angle between them is pi over 2, or in this case 90 degrees. Okay. Now, if the dot product of the two of them equals to 0, then that means those two are definitely orthogonal to one another. Next, writing a vector in terms of its magnitude and direction. This is sort of a review from last time, so there's really nothing new here. So if we have to write a vector, and writing a vector in terms of its magnitude, we are now going to use theta in the I direction plus sine of theta in the j direction. Okay, so this is a review. This one right here is really important, okay? So I want you to really follow along or kind of listen to it first and then write later. Projection of a vector onto another vector. Suppose that vector v and vector w are two non-zero vectors with the same initial point. So I'm just gonna pause right there, do a little sketch so we have kind of an understanding visually of what I'm trying to say. Okay, so let's do vector v here. Okay, let's do vector w this way. It just said as long as in the same starting point, okay? Keep on going. V, vector V, is decomposed into V sub 1, give yourself some space, and V sub 2, okay? Well, how do I get this V sub 1 and V sub 2? Well, I'm going to use two different colors, okay? Decompose meaning I'm breaking that into two pieces, okay? So V equals, okay, decompose means I'm breaking it into two pieces. Let's call this right here V sub 1, V1. And if I take V1 and I add V2, I would definitely have vector V, okay? So how do I decompose and how do I find what V1 is, okay? V1 is vector V regular dot product with vector W all over the magnitude of W squared times, okay, times vector W. That's what V1 is. And V2 is much simpler. I can just take my regular V, subtract V1, okay? So V1 is decomposed into two, V1 and V2, okay? Now, V1 has a special name, okay? So V1, vector V1, is parallel to vector W, okay? And vector V2 is orthogonal to vector W, okay? And V1 has, like I said, a special name. We call vector V1 is the projection of vector V onto vector W, okay? So V1 is really important, okay? In the book, oftentimes it will use two different variables. You know, it can say, oh, find the projection of F into, like, let's say F and H, okay? F onto H. But the mathematics behind it is still the same, okay? So let's check out my drawing to see if the statement is true, okay? This statement right here said, hey, V1 has to be parallel to W. Well, that's really true, right? W is the green. W is the green. And V1 is definitely parallel to the W. Then it went on and say, well, V2, is it perpendicular to W? Sure it is, right? This is 90 degrees right here. So V2 is shooting straight up. And is V1 plus V2 equals to just V? Sure, okay? Because if V2 equals V minus V1, then if I were to do some basic math, right? Oops, this is supposed to be vector. If I were to do some basic math, I can add V1 back to the left-hand side, and that equals to V, okay? So all of that right there is true. Now we are going to use right away all of these definitions. Example 1, find the dot product. Da-da-da. Okay, so I'm giving to you in the bottom here, V, vector V is negative 2i plus 12j. Vector W is positive 2i plus 3j. The dot product, if you remember just a minute ago, is the first component times the first component of V times the first component of W plus the first component on J times the first component on J of W. Okay, so the first component is negative 2 times 2 plus 12 times 3. This is negative 4 plus 36. So the dot product is just a constant here, and that gives me a 32. Okay. Find the angle between V and W. This is when we have to use cosine. No, you may not use tangent inverse anymore. So cosine is the dot product of V and W all over the product of their magnitude. Okay. So the dot product, we found it already at 32. Okay. The magnitude, I need to do it by hand. So here we go. Square root of V So that's going to be negative 2 square plus 12 square times the magnitude of w, which is 2 square plus 3 square. This is now 32 equals 2 square is 4, 12 square is 144, that's 148 times 2 square is 4 plus 9, that's 13, okay. So 148 times 13, let me bust out my calculator. It's going to be 1924. Okay, so that's just basic math. Now this equals to cosine of theta. I need to find theta, so now I need to use cosine inverse. Okay, so it's going to be 32 divided by square root of 1924. Punch into my calculator. My angle comes out to be 43 degrees. And that looks pretty good. So that's my final answer. C, state whether the vectors are parallel or orthogonal. Okay, so to be parallel, remember we talked about this just a minute ago. To be parallel, the angle in between the two of them has to be 0 or pi, or 0 and 180. To be parallel, the angle has to be pi over, to be perpendicular or orthogonal, the angle has to be pi over 2. So this is 43, so it's neither. Okay, so neither. Example 2. Decompose V into vectors. Okay, ooh, we're using the decomposing now. Decompose V into 2 vectors. Let's call it V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. So how do we decompose? How do we find V1? Remember, V1 is the projection of V onto W, okay? And V1 is super important. We're going to need to know how to do V1 all the time, okay? So to find V1, if you go back to our notes up here, we're going to need to do the dot product of V and W, okay? So it says the dot product, of V and W, okay? All over W, the magnitude of W, and square. Once we have that constant, we are now going to multiply to vector W. And how would we get V2? V2 is, I would take vector V, take away V1 once I know what it is. So let's work out what V1 is, okay? The magnitude of, the dot product, of V and W, we found that earlier from the step above, so that kind of saved me some time, okay? So right there. So this, right away, I can just go and write 32 all over. The magnitude of W, we kind of found that earlier as well. We knew that was square root of 13, okay? But I need to square that. So square root of 13, and I need to square that. So, and then whatever W is, I need to, W is 2i. I need to multiply it back, plus 3j. Okay. So on the top, I now have 32. On the bottom, square root and square, that's now just 13. And I need to make this line a little bit shorter. So now I would just multiply to 2 vector I plus 3j. Let's simplify this, okay, so I can get a v subscript 1 in a nicer way. So let's multiply. 32 over 3 times 2, it's going to be 64 over 13, okay, 64 over 13 in the I direction, plus 32 times 3 is going to be 96 over 13 in the j direction, and this is your v subscript 1. To get v subscript 2, you would need to take away v1 is negative 2i plus 12j. Take away your v1, which is 64 over 13, I plus 96 over 13j. I'm going to convert everything into common denominator of 13. So this tells me if this is 13 on the bottom, on the top, 13 times negative 2 is now negative 26, okay? And then plus 13 here as well. So when I multiply that by 13, hopefully I will come up with a nice number. So let's see. What is 13? Multiply this, right? 13 times 12. So, I'm sorry, times 13. So 13 times 12, 6, 2, 3, 1. So 156. Okay, so that's 156. So that's 156, and then this is the j direction. So just kind of combine, just kind of find a common denominator first, okay? So, and then drop this down, 64 over 13i plus 96 over 13j. So now I can put the i's and the j's together, okay? So here we go. Keep on going. These two can go together. Okay. So it's going to be a negative and a negative, so that's going to make it a fatter negative. So that's going to be a negative 90 over 13. So negative 90 over 13 in the I direction. And then, let me just erase this so I have more room. And this right here, this two guys right here, remember I'm subtracting. So 156, take away 96, so I have a nice number. And so that's going to be 60, positive 60 over 13, and that's in the j direction. So this right here, class, is what v subscript 2 vector. I need to go back and add vector. So what's v subscript 2 is. Now, so we took one vector v and we decomposed. We broke it into two vectors, okay? So if I take v1 and v2 and add them together, I should get the original v back. Now remember, v1 is what we call the projection of v onto w. So keep that in mind. That thing's going to come back again and again, okay? All right, and I think I'm going to stop right here. I'm going to save the word problems for class time. Have a wonderful night.